Hello and welcome to T Academy. In today's lecture, we'll learn how to plot a function using factor theorem. The factor theorem says that if we have an f of x, such as this one, then if we can find a p such that f of p is equal to 0, then x minus p will then be a factor of f of x. So let's find out at which values of p the function f of x becomes equal to 0, and then we can say that x minus p is a factor of f of x. So let's check out at some values of p. So first we will start with p equals to 0. So at p equals to 0, f of 0 would become 2 times 0 cube plus 0 square minus 18 times 0 minus 9. This would become equal to minus 9. So since f of 0 is not equal to 0, this is not a factor of f of x. Let's go further and try with p equals to 1. So now f of 1 will be equal to 2 times 1 cube plus 1 square minus 18 times 1 minus 9. So this will become equal to 2 plus 1, 3, minus 18, minus 15, minus 9 equal to minus 24. So x minus 1 is also not a factor of f of x, just like x is not a factor of f of x. Let's go further and try with p equals to 2. And f of 2 will be equal to 2 times 2 cubed plus 2 squared minus 18 times 2 minus 9. So 2 cubed would be 8 times 2, 16 plus 4 minus 36 minus 9. This would be 20 minus 36 minus 16 minus 9. So this is equal to minus 25, and we know that x minus 2 is also not a factor of f of x. Let's now try with p equals to 3. Then f of 3 would be equal to 2 times 3 to the power 3 plus 3 squared minus 18 times 3 minus 9. So simplifying this, we'll get 54 plus 9 minus 54 minus 9, and this indeed is equal to 0. So we have found out that x minus 3 is a factor of f of x given by this equation. So this is the first step where we have applied factor theorem and found out one factor of f of x. So now we know that if x minus 3 is a factor of f of x given by 2x cubed plus x squared minus 18x minus 9, then if I divide my f of x by its factor x minus 3, then the remainder should be equal to 0. So in this way we can further factorize this cubic equation. So let's go ahead and divide this cubic equation. So in order to get 2x cubed, I will multiply x with 2x squared. So this will give me 2x cubed here plus 2x squared multiplied by minus 3. I will get minus 6x squared. Then subtracting this, I will get 7x squared, and these will just drop down. 7x squared minus 18x minus 9. Next, in order to get 7x squared, I will multiply x with 7x, 2x squared plus 7x. This will give me 7x squared plus 7x times minus 3. This will be minus 21x. Again, changing the sign. Here I will get 21 minus 18. This would be 3x, and this minus 9 will drop down. And lastly, in order to get 3x, I will multiply x with 3. So this will give me 3x times 3 minus 3 would be minus 9. So when I subtract this, indeed I get a remainder of 0. So from this long division, we can conclude now that 2x cubed plus x squared minus 18x minus 9 can be written as a multiplication of two factors, x minus 3 being the first linear term, times this quadratic equation. So 2x squared plus 7x plus 3. Next, we will further factorize this quadratic equation to find out linear factors of this cubic equation, and this will make the plotting of this function really easy and intuitive. So we found out this quadratic equation, 2x squared plus 7x plus 3, and this can be very easily factorized. We have to write 7x as a combination of two terms such that when these two terms are multiplied, we get the multiplication of these two terms, so 6x squared, and when these are added, we get the term in the middle, 7x. So indeed, if I write 7x as a combination of 6x plus x, then the multiplication would be 6x squared and their addition would be 7x. It's very simple factorization of a quadratic equation. So 2x squared plus 6x plus x plus 3, and let's first take 2x common from the first two terms. This will give me x plus 3. Then taking 1 common from the last two terms, we will have x plus 3 inside brackets. And then taking x plus 3 common from this equation, we will get x plus 3 times 2x plus 1. So this quadratic equation, 2x squared plus 7x plus 3, can be written as two linear terms, x plus 3 times 2x plus 1. So this now means that our original quadratic equation, 2x cubed plus x squared minus 18x minus 9, can be written as a multiplication of three linear terms, x plus 3, 2x plus 1, and the initial factor x minus 3, which we found out from factor theorem. So this was our original f of x, and we know that this f of x, so this f of x will become equal to 0 when either of these three factors become equal to 0. So we will have f of x equal to 0 when x equals to minus 3, so this is the first term, or when 2x plus 1 is equal to 0, which gives x is equal to minus half, and from this last term x equals to 3. So these three are the roots of f of x, and our function would be 0 at these corresponding values. So let's now go ahead and plot this function. So here we have the f of x which we want to plot, and we already know that this function should be equal to 0 at x is equal to minus 3, also at x is equal to 3, and at x is equal to minus half. Also, we are interested in finding out how the function behaves at x is equal to minus infinity and at x is equal to infinity. So if I plug in minus infinity into this equation, then clearly f of x will also approach minus infinity, and similarly at infinity the function will go to infinity. Let's try to locate these points on our Cartesian plane. So we have our first point at x is equal to minus 3, where the function will be equal to 0. Then at x is equal to minus half, which will be in between minus 1 and 0. And also at x is equal to 3, f of x will be equal to 0. So we know that at minus infinity, when x is coming from minus infinity, f of x is also coming from minus infinity. So it will come like this and will cross the x-axis at x is equal to minus 3. And it will go like this. But then it has to cross the x-axis again at minus half. So somewhere it will go back down and cross the x-axis again at minus half. Then it will continue to go down, but then it has to cross the x-axis again at x is equal to 3. And then when x approaches infinity, f of x will also go to infinity. So this is what my plot of f of x will look like. So that's it for today's lecture. I hope it was useful. Stay tuned to my channel and I'll see you again with some other topic related to calculus. Thank you.